Welcome to Pre-Calculus, Essential Standard 6, Lesson number 4 over solving trigonometric equations. First, we want to do a quick review over what we did in the first 3 lessons. So the first problem says evaluate the sine of 7 pi over 2. Remember, if you subtract 2 pi off of that, so that is subtracting 4 pi over 2, we would get the sine of 3 pi over 2. Remember, that's because 7 pi over 2 and 3 pi over 2 are what we call coterminal. So 3 pi over 2 is down here on the y-axis at the point 0, -1. Every point is cosine sine on our unit circle, so the sine of 3 pi over 2 has a value of -1. Evaluate the tangent of 270 degrees. Remember that 270 degrees is also here at the point 0, -1. The tangent is equal to sine of 270 divided by the cosine of 270. So sine of 270 is -1. The cosine is 0. -1 divided by 0 is undefined. So our answer for the second problem would be undefined. The third problem says given the secant of theta is equal to -3/2 and theta is between pi and 2 pi, find the remaining trig functions. So I'm going to draw a set of coordinate planes down here, and I know that theta is between pi and 2 pi. So that means it cannot be in quadrant 1 or 2. The secant is -3/2, which means that the cosine of theta would be -2/3, since those are reciprocal functions. So where the cosine is negative, so if we think about all students take calculus, cosine is positive in quadrants 1 and 4. Since it's negative, it cannot be in quadrant 4. So the only possible quadrant to draw it in is in quadrant 3. So I'm going to draw a triangle in standard position in quadrant 3. The cosine is equal to -2/3. Remember that cosine is adjacent over hypotenuse. So I'm going to label my adjacent. So here's my theta, my adjacent as 2, my hypotenuse is 3, and now I am ready to use the Pythagorean theorem to find the other leg. So I'm going to do 2 squared plus y squared equals 3 squared. So y squared is equal to 5, so y is equal to plus or minus the square root of 5. I'm not worried about the plus or minus sign at this point because I can worry about the positive or negative of the trig functions at the very end of the problem. So the sine of theta would be equal to the opposite over hypotenuse, so that's the square root of 5, sorry about that, the square root of 5 over 3. In quadrant 3, the sine is negative. I already know the cosine of theta is -2/3. The tangent of theta is equal to the opposite over the adjacent, so that's the square root of 5 over 2. In quadrant 3, it's positive. The cosecant is equal to the reciprocal of the sine function, so that's -3 over the square root of 5, which we rationalize the denominator to get -3 square root of 5 over 5. The secant we've already found, so the last one is the cotangent of theta would be the reciprocal of the tangent function, so that's 2 over the square root of 5, which rationalizes to be the square root of 5 times by 2 all over 5. So that should be a good warm-up for us. Now we want to actually get into today's lesson. It says solve the sine of theta equals the square root of 2 over 2, and we are only looking for angles between 0 and 360. First thing I notice is that the sine of theta is positive. So I draw in all students take calculus, and I notice that it could not occur in quadrants 3 or 4. So I'm going to go ahead and draw a right triangle in standard position into quadrants 1 and 2. If I unrationalize this denominator, or this numerator, so it's equal to the square root of 2 over 2. If I multiply top and bottom by the square root of 2, I end up with 2 over 2 square root of 2, which would simplify to be 1 over the square root of 2. If you just remember that when we originally did our right triangles in the unit circle, we had a square root of 2 on the bottom. We rationalized it and came to this answer. We're just doing the reverse of it. So we want to label our opposite and our hypotenuse. So our opposite is 1. The hypotenuse is the square root of 2. Our opposite is 1. The hypotenuse is the square root of 2, with our theta down here. The purpose of unrationalizing our denominator is that now we can look at this right triangle, and if we did the Pythagorean theorem where we'd say x squared plus 1 squared equals the square root of 2 squared, we would find that this is a length of 1. This matches up exactly with a 45-45-90 triangle. So I know that those two angles are 45 degrees. So my angle theta has an answer of 45 degrees, or this angle here is 45 degrees as well. Remember that this is at 180, so 45 degrees before 180 is 135 degrees. Or in other words, this angle here is 135 degrees. So we can see that the sine of 45 degrees is equal to the square root of 2 over 2, and the sine of 135 degrees is the square root of 2 over 2. I can verify this in a variety of ways. If we look back to the unit circle that we did on lesson 2, we can see that at 45 degrees, the sine value, or the y value, was the square root of 2 over 2, and also at 135 degrees, the y value was the square root of 2 over 2. I could also use a calculator, even though this isn't allowed on your test, but just here in the introductory part of it, if we look at what the actual value of the square root of 2 over 2 is, we see that we get a value of 0.707. If we typed into our calculator the sine of 45 degrees, verifying that we're set on degrees, so I went to mode to set it to degrees, we see that we get that exact same value. If I typed in the sine of 135 degrees, I get the same value as well. Those are the only two values in our unit circle, or in other words, for values of theta between 0 and 360, where I would get that value. The next problem, we want to solve for the secant of theta equals negative 2 square root of 3 over 3. Again, this does not seem to give us any values that match up with our special right triangles, so I am going to rationalize the numerator to simplify this problem. So I'm going to multiply top and bottom by the square root of 3 over the square root of 3, and I end up with negative 6 over 3 square root of 3, which simplifies to be negative 2 over the square root of 3. So I now have the secant of theta equals negative 2 over the square root of 3. Using the reciprocal functions, we would see that the cosine of theta is equal to negative square root of 3 over 2. So now I move over to my coordinate plane, and I label all students take calculus, and I want to see where the cosine is negative. That means it cannot be in quadrant 1 or quadrant 2. So I'm going to draw a right triangle here in I cannot be in 1 or 4. So I'm going to draw a right triangle in standard position in quadrant 2 and do the same thing over here in quadrant 3. Cosine is equal to the adjacent over the hypotenuse. So I'm going to label my adjacent, which for an angle theta here, the x value would be the square root of 3 for the adjacent, and the hypotenuse is going to be 2 in both of them. For this top triangle here, if I did the Pythagorean theorem, x squared plus the square root of 3 squared, so x squared plus 3 is equal to 2 squared, we would get a value of 1. Same thing here on the bottom triangle. This matches up directly with my 30, 60, 90, with the 30 being here at theta. So my answer, if this said between 0 and 360, we would have an answer of theta is equal to 150 degrees or 210 degrees. In other words, that's 30 degrees before 180 and 30 degrees after 180. But since it says for theta between 0 and 2 pi, I need to give my final answer in radian measurement. So my answer in radians is going to be 5 pi over 6 and 7 pi over 6. We could do that a variety of ways. I remember that 30 degrees is always pi over 6, so from a value of pi here at 180, I subtracted 1/6 pi and I added 1/6 pi to get those two answers. Or we could simply take our degree answers times by pi over 180 and we would get to the same point. This next one seems to be a little bit tricky. It asks where the tangent of theta is undefined. So if we think back to the only way to get an answer where it's undefined, I would need to take some number divided by 0. That would give me an undefined. So I could look at this as opposite over adjacent, but I could never draw a triangle that has an adjacent side of 0. So instead, I look at this as equal to the sine over the cosine of theta. So I need to find values where the cosine of theta is equal to 0. So once again, when they ask where the tangent of theta is undefined, it's another way of asking where is the cosine of theta equal to 0. Well, that would only occur at one of our 4 places on our axes. So remember, this is the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And at every point on here is cosine sine. So I have 2 points where the cosine is equal to 0. And that is at pi over 2 and at 3 pi over 2, since it asked for it in radian measurement. They want to know where the cotangent of theta is equal to the square root of 3 over 3. Another way of saying that is that the tangent of theta is equal to 3 over the square root of 3. Once again, this doesn't appear like any of my special right triangles, so I'm going to multiply top and bottom by the square root of 3 over the square root of 3. I end up with 3 square root of 3 over 3, which is equal to the square root of 3 over 1. So we start off again. All students take calculus. I'm looking where the tangent is positive. That means it cannot be in quadrants 2 or 4, but has to occur here in quadrant 1 or quadrant 3. So now I am going to label my opposite and my adjacent. So from my theta, my opposite is the square root of 3, my adjacent is 1. Same thing in this triangle, my opposite is the square root of 3, my adjacent is 1. If I would do the Pythagorean theorem, 1 squared plus the square root of 3 squared is 2. Once we take the square root, this matches up directly with my 30, 60, 90, with this angle down here being 60 degrees. So I would have answers at 60 degrees and at 240 degrees. Now there are a couple things to notice here. It does not tell us whether it wants the final answer in degrees or radians, so I get to choose. That's the good news. The bad news is it also changed it up because it says all values of theta. So it wants us to realize that there are more answers than just 60 and 240. That's because we have to look at all the coterminal angles. So coterminal with 60 degrees would also be 420 degrees, 780 degrees, so on and so forth. We would always add 360 or subtract 360 from that. So our way of writing that is plus 360k for all integers k. And the same thing for the 240. Now you might notice that this is kind of a special case scenario where all of my answers are exactly 180 degrees apart. So we could actually write this in a more in an easier way because of that fact. So we could actually give an optimal answer of 60 degrees plus 180k for any integer k. So in other words, 180 times 1 is 180, 180 times 2 is 360, and I'd always be falling on one of those 2 points once I started out at 60 degrees. This is the end of the notes. Thank you.